For number 1, whenever we plug a value in for x into the least squares regression line, that answer we get back for y, it's the mean value of the response variable. Because for different individuals who have the value x equals 20, they're all going to have slightly different y variables that correspond with that 20. But when you average them all out, that's what our least square regression line is trying to show us, what that average value is for people with an x value of 20. So just plug 20 in here and see what you get, and that is the mean value of your response variable. And that's how they're trying to write it here. The mean value of your response when x is 20. That's what that slash means. So if x is fixed at 20, what's the average for our y?
For number 2, if you look in the textbook on page 700, just the definition of a multiple regression model, you'll see down here it answers the question about that random error term. It's normally distributed with mean 0, and the standard deviation is set there equal to sigma.
For number 9, we have the multiple regression equation already calculated for us. And part A is saying, what's the slope for x1? So we have multiple variables here. If we want to find the slope of a particular one, we assume that that other variable stays at some fixed value. It's not going to change. And so this would be some fixed number that you plug in. It's basically just a constant, kind of like this number here is a constant. And so we're just looking at what's the slope going to be when x changes, and it's that, or when x1 changes, and it's that number that it's multiplied by. So here it's a positive 2. So the slope's a 2. A positive slope means that your y is going to increase 2 units for every 1 unit increase in that x1. So positive 2 increased by 2 for every 1 unit increase. And like I said, we're assuming the other variables are remaining constant. For x2, we're assuming that x1 is remaining constant. And so its slope is a negative 4. So for a 1 unit change in x, our y value is going to go down 4. Decrease by 4 units for every 1 unit change here in x2. And then for the other parts of the problem, they want us to plug values in for x1 and see what effect that has on the graph of our regression equation. So if we're plugging in a 10 for x1, just plug it in there. You'll get 20. And so a negative 5 and a 20 can combine to make 15. And then this part we're not plugging anything in for. So here's our equation when we plugged in a 10. And then graph that. So we're looking for the intercept to be 15 and a negative 4 slope. So these two have a negative slope. This one has an intercept way up by 80. So this one is the one that's right at 15. So it's B. For the next part, plugging in a 15, you get 30. And combine that with 30 and the minus 5, you get 25. So now we have a y-intercept of 25 and still that minus 4 slope. So look at the two ones with the minus 4 slope. This is the one that has the y-intercept at 25. And then do the same thing again for the next part. Plug a 20 in there. You get 40 minus the 5 is 35. So we're looking for y-intercept of 35, the minus 4 slope. So you can see in all of our graphs that slope is the same, because the slope for x2 is the same. So different values for x1, how do they affect the regression equation? They're going to change the y-intercept. And you can see that from your 3 graphs we looked at here. But the slope stays the same.